Hey guys, yeah, so in the last video we got the descriptive statistics and got formulas for each of them. So now here in this video I want to do the last item left in the descriptive statistics, which is what Excel labels as confidence level 95%. It's actually not very clear. It's actually the margin of error. So how are we going to get the margin of error? So I'm just going to remove some formulas here and start. So Z is the standard normal, which has a mean of 0. Type 0 here. Symbol is mu, and then the standard deviation for the standard normal. So this is a standard normal, right, which is in the center. Standard normal. Okay, so this is a standard deviation of 1, so mean of 0 and standard deviation and variance of 1. So it's centered in the middle, so there are two tails, right? Like this, right? So, right, symmetric in the center, that's 0, and the standard deviation of 1, right? Plus 1 minus 1. So there are two tails on both sides. So if we want like a 95% confidence level, right? Here, if we want like a 0.95 confidence level, then we are saying that we want the central area here to be 95%, which then leaves us with 5% in the other two, it tails. So that's 5%. So this is the total tail area, right? Which is basically 1 minus 95. So the formula shows up here. And then the single tail area would just be that total tail area divided by 2, the number of tails. So I'm just doing this because sometimes we have single tailed analysis, but this is two-tailed. So okay, then we know what a z-score is. The z-score basically refers to the distribution of the population, right? So the z-score here is corresponding to the single tail area of 2.5%, right? That's over here. So right. So this is 2.5%. 2.5%. So what is the z at this point? So turns out it's negative 1.96. So it's negative 1.96 standard deviations away from the center. And how we get that in Excel is we use the norm.s.inverse, right? So we get negative 1.96 here, right? And so if you put a negative sign in front of it, you get the z-score for the right side, the right tail. Okay, and so the way the margin of error is calculated is to take the z-score, the positive one, right, and multiply it by the standard error. So that's margin of error. Its formula is over here on the right. All right, so you get 37. Okay, 37.669. But you see, if I were to take that number here and compare what we have in the Excel descriptive statistics, it doesn't exactly match. So I did a bit of digging and realized that the reason why it doesn't exactly match is because in Excel we don't use the this is the Z statistic margin of error, right? That's for use when we know the population, right? So that's when n is the population, but n is not, n is a sample, it's just smaller than the population. So we should use the t statistic. And so how do we get the t statistic? Same logic as before. So we have to use a different formula. We have to use the t dot inverse formula. And here we put in the probability of the tail, right, which is 2.5%. And we also have to put in the count, which is the sample size minus 1. And that gives us negative 1.96, right, which is similar to the Z but slightly different, right? And the negative of that gives us the other, so it's like a t statistic over here. So if this were the Z score, then there's a T score as well, which is also like minus 1.9601, slightly different, right? And then plus 1.9601. So it's slightly different from the Z score. And because of that, we will see differently. So the t-score here, same thing, we take that t-score 1.96007 times the standard error, we get 37.67115002. So if I take that number and I refer to the t of error, which is called, then you see the number exactly matches what Excel is getting, right? So okay, so these are the formulas here. I will just copy them to the right column as well. Okay, and you can see the formulas here in column M. All right, so for small, when the sample size is small, then we should be using, the more we should use the t statistic, and we should not use the population one. So this is because the sample mean is an estimator and there's a bias. All right, so okay, now we have the margin of error calculated in a formula.